This is MSJ Chem, and in this video I'll be looking at magnetism in the transition elements. In this video we'll be looking at the effects of a magnetic field from a neodymium magnet on four compounds: manganese dioxide, nickel nitrate, copper sulfate, and zinc nitrate. So we'll start by looking at the zinc 2+ ion. Here we have the electronic configuration of the Zn2+ ion, and as you can see from the orbital diagram, there are no unpaired d electrons. So let's have a look at the effect of an external magnetic field on the sample of zinc nitrate. And as you can see, the magnet is having no effect on the sample of zinc nitrate. Next we'll look at the copper 2+ ion. Here we have the electronic configuration of the Cu2+ ion, and as you can see from the orbital diagram, it has one unpaired d electron, which is this one here. And let's look at the effect of an external magnetic field on the sample of copper sulfate. As you can see, there is a weak attraction between the magnet and the sample of copper sulfate. Moving on to the nickel 2+ ion. Here we have the electronic configuration of the Ni2+ ion, and as you can see from the orbital diagram, there are two unpaired d electrons. So once again, we'll have a look at the effect of an external magnetic field on the sample of nickel nitrate. And as you can see, there's quite a strong attraction between the magnet and the sample of nickel nitrate. Next, we look at the Mn4+ ion. Here we have the electronic configuration of the Mn4+ ion, and as you can see, it has three unpaired d electrons. And once again, if we introduce an external magnetic field, you can see there is a strong attraction between the magnet and the sample of manganese dioxide. So let's have a summary. The zinc 2+ ion showed no effect in the magnetic field, and it has 0 unpaired 3d electrons. The copper 2+ ion had a weak effect in the magnetic field, and it has one unpaired 3d electron. The nickel 2+ ion showed a stronger effect in the magnetic field, and it has two unpaired 3d electrons. And finally, the Mn4+ ion showed the strongest effect in the magnetic field, and it has three unpaired 3d electrons. So from this, we can see there's an increasing effect in the magnetic field as the number of unpaired d electrons increases. Next, we look at diamagnetism. From the demonstration, you could see that the zinc 2+ ion had no effect in the magnetic field. The zinc 2+ ion is diamagnetic. It has no unpaired electrons. Diamagnetic materials are weakly repelled in an external magnetic field. Next, we look at paramagnetism. So the copper 2+ ion, the nickel 2+ ion, and the manganese 4+ ion all showed an effect in a magnetic field. These three ions are paramagnetic. They have one or more unpaired d electrons. Materials that are paramagnetic have unpaired electrons, and they are attracted by an external magnetic field. Paramagnetism increases with the number of unpaired electrons. And as we saw from the demonstration, with the increasing number of unpaired d electrons, there was an increasing paramagnetic effect. The Mn4+ ion had the strongest effect with its three unpaired d electrons, and the copper ion showed the weakest effect with its one unpaired d electron.